Hello and welcome to Fundamentals of Programming Language Concept course. And today we are going to talk about control flow. We would like to know more about selection, iteration, structured versus unstructured flows, and we would like to have realization in Java and C programming, Java, C, and Erlang programming. I'm gratefully acknowledge the resources and contributions that have enriched the content of these presentation. Control flow is programming in the programming dictates the sequence of a statement execution. It includes sequencing, selection, iteration, construct, vital for controlling program execution based on conditions or loops. Understanding control flow is essential for designing algorithmic programming and writing efficient and logical and structured code. Control flow represents the sequence in which a program constructions are executed. There are two types of control flow exist: structured and unstructured. Structured control flow refers to organized arrangement of a statement within a program. It includes present processing such as selection and iteration. On the other hand, unstructured control flow uses go-to statement or other statement to dictate the flow of control within a program. The statements or program components such as if, while, or return alter the sequence of program execution, like how a reverse flow can be influenced or redirected uh, in the nature. Looking at the pseudocode, we start from beginning and check the statement and then execute certain statement afterward to checking the conditions and executing certain statement, and from top to bottom of the program it goes with the flow similar to the river stream from top to bottom of the hill. Execution order are as follows. The sequencing is the simplest structure. It means that statements will be executed in order they appear in the code. Selections are a runtime condition or the condition to be determined whether there will be a path or alternative path to be selected and executed. Iteration is the process that we use for repeatedly execute certain statements in certain number of time, or we have a specific runtime with respect to the condition to be met. Also, we have abstraction, recursion, concurrency, and non-determinacy that these are all going to be discussed in other chapters. Sequencing represents the fundamental control flow where actions, executions, and evaluation occur consecutively, one after the other. Unlike the sequencing selection structure, which often being called as if-then-else structure, follows the flow that it checks the condition. If the condition is true, there will be one or more statements to be executed. Alternatively, if the condition is not true and it's false, there will be alternative statements to be executed. This is being represented in the algorithmic form with the flowchart and in the syntax, pseudocode syntax. The syntax for the algorithmic syntax or pseudocode for how we form the selection structure are using if statement in Java and C are identical. And here you are looking at the examples for Java and C. Let's run this Java part. Is we initialize time equal 20, then we check the time to be smaller than 18 to print good day. Otherwise, we print good evening. I'm switching to Java here. As you can see, I have this code over here. I'm gonna run this. And as you can see, the output is a good evening because it checks time equal 20 and it is not smaller than 18. That's the reason we go to the alternative solution, which prints good evening. Now I am switching to C. For the C, we have the same. This will be good evening. We have time equal 22. We check the condition for time to be smaller than 10, which prints the good morning. Else, if it checks the time to be smaller than 20, then it prints the good day. Alternatively, it goes with the good evening, which in this case, we have time equal to 20 means that it's not having the condition for the if or else if that's the reason, we end up with the alternative solution. In Erlang, the selection structures are also the same. Here you are looking at if-else condition. This is the condition for true statement. For else, we are using true as for the syntax to have the false statement to be executed. At the end, we are going to have n and dot for the finishing these code to be easily executed. You're looking at the function because it's the functional programming, and we're going to talk about it. We covered it in the next chapter, but focusing on this, we're going to have greeting, and the greeting will take time as input variable. It checks if the time is smaller than 12. It assigns good morning to say variable. If time is smaller than 16, it assigns good afternoon, and alternatively, it assigns good evening. And at the end, we are having the IO format, which says that it is this time which we assign, and we say the second option. So this is the placeholder, this tilde and W for time, and say to be replaced in this syntax. So I'm going to switch to Erlang, and we're all set. And now I'm going to greeting function, and I'm adding, for example, 10. This is we say good morning because it's 10. Now we go for 30, for example. 30 we don't have. We're going to put 20, and it's 20. We say good evening. Iterative structures are basically the structures that we use for executing a sequence of statements repeatedly as long as the condition holds true. Conversely, the condition, if it's not true, the execution comes out of this repetition order. We call this repetitive structure as loop. So the loop checks the condition. If the condition is true, it goes to execute one or more statements, and it goes back and checks the condition. If the condition is true, it's going to repeat this process until unless that we end up with a condition that is not true and it is false, and it goes out of this loop. While loop is one of the very commonly used loop in different programming languages, and here you are checking the condition in front of the while, and if it's true, a sequence of statements will be executed. Here are constructs, an example of while loop in Java and C. Let's run these codes in VS Code to see the result. Going to Java, and for the Java, I'm going to have this code while loop executed. As you can see, we initialize I equals 0, and then we check the condition is for the case that I is supposed to be smaller than 5, and then we are going to print I and it increment in I. So now I'm going to switch to C and do the same. And we assign I equals 0, then while I lesser than 15, we are going to print out the outcome and increment over I, and you can see that we start from the 0 and we end up with 14. The another loop structure is for loop. So for the for loop, there will be a counter and there will be a lower bound and upper bound. It's a start from the lower bound, it ends up with the upper bound, and it repeats the execution of a sequence of statements until the condition is met and it comes out of this loop. So we are looking at here, we are looking at the structures, an example of for loop in both Java and C. Let's execute them in Java. Let's say that this is a Java code, and I'm gonna have this here. I'm gonna execute this. So we assign j equal 0, which is a lower bound. The upper bound is going to be j lesser than 5, and then we are incrementing one after each other for j, and we print out j for each step. As you can see, we start from the 0 and we end up with 4. We're gonna do the same for C. As you can see, we started on the lower bound, I equal 0, and upper bound is exactly the same, is I smaller than 5, and we increment over I, and we are going to have, we start from the 0 and we end up with 4. Exactly similar what we got in Java. Java has two more construct for loops for each, and do while for each is extensively used for kind of accessing to elements of an array. Here you are looking at an array which contains string as each element of an array. So we kind of load the elements by different names, strings like a Volvo, the names of the car. So you have Volvo, BMW, Ford, and Mazda. These are made of the car. And what we do, we loop over these I and V one by one. We print out the outcome. I'm going to switch to Java to show you how it works if you want to implement that. So I'm having the Java code here, and I'm going to run this. You're going to see that we construct an array which contains different strings, and for each string, we go and print out the outcome. We go to the Volvo, BMW, Ford, and so on. Going back to do while loop is always is a loop that it will use, as you can see here in the pseudo, it will be always execute the first at least one time, and then the reason is that, as you can see, the execution occurs before checking the condition. So it means that it goes down, it checks the condition, and it's not met, it's kind of comes out of the loop. For that specific example, I'm gonna go back to Java again, and I'm gonna have this do while loop here, and I'm gonna execute this. As you can see, we start from I equals 0, and then we print out the I, and we increase in I, and we check that I supposed to be, the condition is I supposed to be smaller than 5. Let's say that I'm changing these and I'm putting as 0. Let's see what's going to happen. We start with the I0, but we check that I supposed to be smaller than 0. But let's say, as you can see, the output is going to be at least one. It's going to be one time executing, in fact, printing the I, which was 0, and then it comes and it checks that I is going to be 1 in this case scenario, and 1 is greater than 0. That's the reason the program, the condition is not met, and it comes out of the loop. Erlang, as a functional programming language, does not have while or for loops. Alternatively, we can use recursion, which I'm going to talk about it in the next chapter, to implement the iteration. In general, the functional programming languages have no loops because changing values is forbidden. Instead of assigning a new value to a local variable, we have to make the recursive call and pass the new value as an argument. As you can see here, we have the function, which I'm going to talk about the functions as well. So it's going to have this is called factorial, and the factorial is being used reading the function that kind of imitate the iterative structure in functional programming language. In summary, we discussed sequencing, iteration, and selection. For sequencing, we start from the top to bottom, very simple. The way that it is written in the code is going to be executed. For selection, we had the condition. If the condition was true, it's going to print out, for example, one or more statements. Alternatively, if the condition is not met, it's going to execute alternative statements. For iteration, there will be a condition. Once the condition is met, there will be a loop over data until the condition is false and it comes out of the loop. Next chapter, we are going to talk about structured versus unstructured flow. Since we already know the loops and everything, we are going to talk about go-to statement, and we are going to talk about break and continue and switches to be familiar with all of these concepts. And at the end, we are going to talk about functions. Thank you.